What's up, guys? This is the Livin the Dream podcast. I'm Sam, and welcome back to another great episode where we dive into all things blue collar, whether that's climbing a ladder or crawling in a ditch. We cover everything. So how about you go over to the YouTubes? If you're already here watching this, you probably are. Give us a like and subscribe. Drop us a comment. Follow us on Facebook. We're also on Apple Podcasts and Spotify. So how about you guys just sit back, relax, crack you a cold one. We'll do the rest. Let's dive into it. Welcome back, guys, to another episode of Livin the Dream podcast. And today it's just little old me. And I'm going to do a little discussion about persistence because, let's be honest, the last 8 days of my blue-collar career have been about persistence. And I say that because I work in maintenance, and you run into some problems that they don't fit anything that you've ever worked on before. And this is one of those problems. I've never seen it before. Everybody around me was like, no. When we finally found the problem, they were like, well, it might. Even I was skeptical. I was like, I don't know. I hope that it's the right, that it was the right solution, but I didn't know. Because it didn't make any sense. I'm like, how is that possible? But so far, now I say so far, as I record this right now, the fix is good. But it may be different tomorrow morning. I don't know. We'll see. But I will say that, we'll lay it out here. So it's contact relay is what the problem ended up being. And it worked with the safety PLC, and it applied voltage to the power supply, which applied voltage to the drives. Now, if I'm getting a little too technical here, CNC machines, so on and so forth. I'll do my best to try and keep it layman's terms, but moral of the story is it's a light switch. When somebody comes along and the computer flicks the light switch on, it sends the power on through, and it makes everything work. But a lot of times on CNCs, you'll have a failure, and it'll pop up with an error code. The newer ones, let me rephrase that, the newer ones, for all you guys that are out there that are watching this, that are the old school maintenance guys that have dealt with, like bang circuitry for turning motors on and off, stuff like that. I know, you didn't get the errors. You had to go through with your meter, and you had to test it. We're not talking about those machines, okay? We're talking about new age, fancy schmancy HMI, human-machine interface. And a lot of times when you have a failure or an error or something along that lines, it'll pop up with a message on screen that says, failure X-axis, failure Y-axis, over travel, under travel, something along that lines. It'll give you something that will tell you, hey, go look in this spot. Okay? This did not. It didn't at all. Most machines, the newer ones, have an emergency stop circuit, which it kind of, the older ones, it would go in a loop. Okay, so if you had one switch fail, it broke the loop, and that shut everything down. Well, the more sophisticated ones, you have individual loops. Like it goes there and back, there and back, there and back. So you've got one central location, and you've got all of these other little trails that go off to the individual emergency stop buttons or over travel switches, or the oh shit sensors. Okay, when something goes wrong, that all tracks back to this safety PLC. So sometimes you can have a relay or something like that in between the safety PLC and the power supply for the drives or what have you, to as like a buffer, because you have power surges and you have failures and stuff like that, and it's a forwards and backwards deal. It's, if you have a surge coming from the power supply, then it breaks the contact. If you have a surge coming from the safety PLC side, then it'll break the contact, so on and so forth. It's a sacrificial thing. Well, what I learned today is the way that this certain machine is set up is that so it's a 24 volt DC setup. So you have a contact so you have one wire that comes in that's 24 volts, and then you have another wire that comes in to that same coil for the contactor that is, I'm sorry if I'm pausing a lot here. I'm trying to make sure I'm explaining this well and accurate as well. So you have the common and you have the 24 volt. If you remove the common side of it, which I think this is where that whole, you have the loop or you have the there and back scenario. If you remove the common, it gives you the alarm, which that was what we didn't understand. We're like, well, why? Why are we... So you remove the common side, and it gives the error. But if you remove the 24 volt side of it, it just gives an emergency stop, and it doesn't tell you what it is. It just goes away. So the way the contactors work is there is an electromagnet that closes the circuit, and that's what either opens or closes, because it was a normally open or a normally closed circuit. It wasn't like an and circuit, so it was like it had to close one and open the other, if I'm understanding it correctly, and I'm probably wrong. I believe I was told that that's not correct, that it's an and, but I don't see how that's possible after seeing the mechanism. Anyhow, that's something I'll address later on. Whatever, that's for my knowledge. What we're going over today is persistence. And attention to detail. So we had replaced, before this contact relay, we'd replaced after the contact relay. But we didn't replace the contact relay. So that's what got us, was the contact relay. And we end up, I can't remember if it was we mistakenly pressed on it or something along the lines, or we discovered it while we were reviewing the wiring diagram, or what. I don't remember what it was. All I know is it was 8 days of troubleshooting and trying to get this error to replicate. That was the other thing, is it didn't have any consistency. Like, I've had broken wires before in cables that, you put the machine in the same spot and it fails every time. And that's great. That makes things so much easier. Like, it doesn't seem like it, but it does, because if it fails in the same spot, then you can start looking at the wire loom and stuff like that, because it gives you a place to look at. But this did not, because it would fail just sitting still. And that was what baffled us more than anything, and it didn't fail sitting still in the same spot all the time. It would fail in a different spot all the time. And even when we were moving it around and operating and stuff like that, sometimes it would fail in this position, sometimes it would fail in this position. Now, it did start kind of repeating a failure in a similar position, and I say similar because it was never still in the same spot. But then, so we were like, oh crap, it's wire, so we're going to have to start wringing out cable and stuff like that. But it didn't. And I don't remember, and that bothers me so much now that I can't remember where it's at, how we discovered it. But it was one of those things to where we were, once we figured it out, we were able to consistently replicate the problem. And it was through persistence and continuing to, narrow down the problems, what could cause it, what couldn't cause it. Are we seeing a failure in the power? No, we're not seeing a failure in the power. Is it, it's just one of those deals to where we had to keep plugging away at it and narrowing things down step by step, area by area, in order to finally come to this. And I honestly feel like it was almost dumb luck that we came to this relay, because I don't think any of us really thought that it was the relay. But when it came down to it, you could press on it lightly and it would give us the error. And so it was either there was a short somewhere in the coil or something along that lines that caused the failure. It was a very difficult problem to find, if that ends up being the problem. I mean, we're still at this point in time. Maybe next episode I'll give you a confirmation as to whether or not it was actually the problem. But I feel like it is. I feel pretty confident in it because of all of the persistence that we had and being able to narrow down different situations. I feel like we've got it. I feel like it's wrapped up. But so I tell you that story to tell you that it was 8 days of the same machine, day in, day out, going over different things, reaching out to different people, checking different avenues, different possibilities, and trying to determine what could possibly cause this failure. It took every resource that I had, every resource that the OEM technician that was there had, to get down to this point, because even when the OEM was suggesting that it was that relay, we were like, I don't know about that. So sometimes it takes, you've got to look at the different options, and sometimes it's just one of those deals to where it may not sound right, but it may be far-fetched. For instance, okay, so there's another thing. There was a failure at another machine that the alignment was going out in the Z-axis, 6th out. It was drifting. And we're like, what the heck? There's no way. So it turns out, and this is, the next episode is going to feature Bryant James, by the way. He's coming over, and we're going to hammer out some episodes. But, oh my Lord, it's gone. Coefficient of thermal expansion came into play on that one, because as there's a ball screw, so you have, it's a spiraled rod at that point, and there's bearings that track around that spiral, and through the motor it's able to go up and down and up and down. So as it was going up and down and up and down like that, it was heating up the ball screw, or the screw aspect of it, and it was expanding 6,000ths. And the only way they found it was they ran it all day, and they put an indicator on the spindle face, and it left it alone and came back the next day, and it had moved exactly that 6,000ths. Sometimes it takes things like that, just thinking outside of the box, that who in the world would have ever thought that something that is designed to be very precise can have that much growth in it whenever it's in use. So that's something. There's so many things that require persistence. For instance, this tractor, okay? You can't tell right now, but it is in 2 pieces. There is no engine over here. It's on the floor. because I'm going to have to use some parts out of it, some parts out of the other engine. If you watched our live stream, which if you guys aren't part of our Facebook page, you need to be part of the Facebook page. And if your friends and family aren't part of our Facebook page, they need to be part of our Facebook page. Because it's summertime, and we're going to be doing things like tearing tractors in half, going to tractor shows, doing all kinds of different things, and y'all are going to miss it if you're not part of the Facebook page. Because the Facebook page, honestly, is probably the thing that I will update the most. You may notice that you didn't get an episode last week. Well, you didn't get an episode last week because we did a live stream last week. Was that planned? Absolutely not. Do we plan on doing more live streams? Probably. Most likely. Because I just went through and set up all of the live streams to where we can stream on multiple platforms. Hopefully my internet can handle it. We'll find out. If you tune into the live stream, you'll know whether or not my internet can handle it. We got tractor shows coming up. We got truck shows coming up, I'm sure. There's going to be things when I get this old girl back together, which there are parts that are supposed to be here tomorrow. So there may be a live stream after you see this episode. I don't know. I haven't figured that out yet. It all depends on how work goes tomorrow. But, you know, I work a regular blue-collar job. Persistence has probably been the single most important tool that I've had in my tool bag, because even when I didn't know how to fix a lot of things, being persistent, pushing forward, asking, searching for the solutions, you know, reaching out to the OEMs, talking with the OEMs, getting an OEM there, and then when they're there, not leaving their side. You know, and then a lot of times, like even the guy that was there today was like, I really don't need you here. I was like, I understand you don't need me here, but I need to be here because there may be some harebrained question that pops into my head that I have had for a long time that I can ask you, that you can ask the right people. So it's just opportunities like that. When you have the ability to have an OEM technician there, utilize it. Like, just soak all the information. If you have a calibration guy there, like Mr. James, that's going to be here next week, soak up as much information as you can, because a lot of times you can use that information to help troubleshoot. We had, there's all kinds of tools that you can use at your disposal with technology nowadays. It's insane. We used a GoPro to help us to troubleshoot the issue with the contact relay. Had it in the cabinet. It was recording. Boom. We were able to capture the failure and see, you know, the things that were occurring that we weren't able to see because of how it was failing. So it's things like that. You've got to be able to think outside of the box. You've got to try different things. And just, man, anything's a possibility. Anymore, I'm like, I try not to disregard anything that someone suggests could be a point of failure if I'm troubleshooting something like that, because at this point, I've seen so many things that didn't make any sense to me whatsoever, and it ended up being the root cause of the problem. Man, who would have thought? But sometimes you've got to utilize that technology. There's attachments now for your camera, for your phone, that you can have a thermal imaging camera in your hand. And that was a big part of it too. We were able to track heat signatures on those relays, and they were high. So, you know, when you have a high heat signature like that, a lot of times that means that you've got a high amp draw. If you've got a high amp draw in a coil, then there's a good possibility that there's something damaged in that coil, or there's a bad connection somewhere that will create a higher amp draw. So, I don't know. This was probably more of a diary or just a blog just for me to, I don't know, words are escaping me right now. Just a matter, it's just a way for me to document. There we go. For me to document what's occurred and the situation that I learned from, because it was very challenging and very frustrating. It was one of those deals to where I explained it to someone today. I said we had there's several dents in the wall, and we finally found a soft spot and we had a breakthrough. And if you think about that, when you're banging your head against a wall, if you're hitting on a stud and you're not going through the wall, but you hit one of those pockets with no insulation or something like that, boom, you're going right through that sheetrock. So there you go. There's your goofy term for the day. Maybe you can use that later on, like you're banging your head against the wall and you had a breakthrough because you found a soft spot. So this has been Livin the Dream podcast. I'm Sam. Thank you guys so much for listening. I hope maybe you learned a little bit about some of the circuitry. I know I kept it kind of vague. If you have any questions or you didn't understand something I said, please feel free. Drop a comment down in the YouTubes. Send me a message on Facebook. Comment on the Facebook page. Don't hesitate to interact, folks, because we don't know you're watching unless you interact, and we can't answer your questions unless you ask them. So we'll see you next time. If you're late, you're lost.